All right, I'm glad you're here. Here's the second part of our notes for today. And we want to make sure everybody knows this is part 2 of week number 6 for sure. I can determine next terms in arithmetic series. Now we need to take a minute and talk about this word, because what we've already heard is this is familiar. Arithmetic means adding. And remember, that was where we had that common difference for sure. But we had been talking about a sequence, and that was where we just had a list of terms, right? So now all of a sudden we see this new word series, and we're curious about how things are going to change. Okay, while you may think of a sequence as a list of numbers, and that's, remember, that's defined by that rule. That was that function or that equation that we were able to write about it. Here's the cool thing. Our series is going to be the sum of all of the terms in that sequence. Okay, so we're going to mostly deal with the sum of the first n terms. Now what ends up happening, think about those finite and infinite sequences. If you have an infinite sequence, you're not going to be able to add everything up. But if you have a finite sequence, then you can find, and that says, hey, can you tell me the sum of the first 100 terms, or the sum of the first 50 terms, whatever you need. Okay, so here's my sequence. Here's my a sub 1, 2, 3, 4. My n, my first, second, third, fourth term. My s sub n, and we'll have that highlighted for us, is going to be equal to all of those terms all the way up to and including this last term. And n, don't forget, is going to tell you which number of terms you're talking about. So another way that we can write it is using this sigma, which is the summation sign. It's a Greek letter that means add them all up. So when you add them up, this n tells you how many of the terms that you're going to be adding up. So let's break this formula down a little bit more. This last term is going to be determined by this n and this n. So I want all the numbers added up to and included that term. And here's where I want you to start. This first term is where I want you to start. So notice we have this interesting idea of I here and I here. And that's going to be our notation for adding up all the terms in whatever formula we have, and that's going to be whatever formula we're given from 1 up to this n, add them all up, and that's what we get. Okay, now going back to what we said before, a finite series is the sum of all the finite terms. That's where it ends. An infinite, when you're used to that symbol, series is going to be the sum of all the terms. And guess what? That's when n goes on to infinity. And you'll find that that's going to be one you can very easily say, no can do, I'm not going to be able to do that. All right, let's look at some examples. It's always easier to understand with a sample. So for this first one, all we have to do is take a look and see, is it an infinite or a finite sequence or series? So here we have a series. It's a list of terms, and guess what I see? Which means this one is definitely going to be an infinite sequence. When we look at number 2, some things are different. Now all of a sudden I have these addition signs. It's not a common difference. So what I'm doing is I'm taking a sum of this whole series, and then it ends. I don't see any dots, which means this is a finite, and it's going to be a series because I see those plus signs. If somebody asked me to find the sum of this, I could. A plus 1 is 9. 9 minus 6 is 3. 3 plus negative 13 is negative 10. Negative 10 plus negative 20, that sum is going to be equal to negative 30. That's going to be that sum of all those numbers. All right, here's a new symbol for you. It's called a sigma, and we're going to show you how it works. It's intimidating at first, but you can quickly figure it out, and it's going to make you feel so smart when you see it and how it is that it works. All right, so our directions say use the summation notation to write out the series and find its sum. Round to 2 decimals if needed. So the I that you see here is not our complex number or our imaginary number. It just represents which item we're going to have. So when we have each of the members of the series, we're going to have our first and our second and our third and our fourth and our fifth, because we're going to put 1 through 5 all the way into this. So we're going to say 3 times 1 plus 3 times 2 plus 3 times 3 plus 3 times 4 plus 3 times 5. So we're finding the sum of the series of 3 times some value for I, and that I is going to go from 1 all the way up to 5. So 3 plus 6 plus 9 plus 12 plus 15. So either grab your calculator, have some fun with your mental math. I know that 12 and 3 is 15, 15 and 15 is 30. So I can do some mental math by doing that. 6 and 9 are 15, so 15, and my other 30 is going to be 45. So 45 is my sum of 3 times each of those values. All right, let's try another one. Let's pick this apart and see what it's asking us to do. We're going to start at a value of 3, and we're going to go up to a value of 6. So we're going to say I is equal to 3 and 4 and 5 and 6. So what we're going to do is put that into each of these values and add them together. Stick with me here. So we're going to say the opposite of 3 plus 6 plus the opposite of 4 plus 6 plus the opposite of 5 plus 6 plus the opposite of 6 plus 6. So take a minute and make sure you understand where I got all those numbers from. All right, so when we simplify this, this would be negative 9 plus, and then we're going to have negative 10 plus, and then we're going to have negative 11 plus negative 12. So you can see that I put the start number in first, and I went all the way up by 1 until I reached my last input value for I. So then now my job is just to add them together. I'm going to do the same thing I did before. I'm going to add my friendly numbers. I know that this is negative 22 and that's negative 22, so it looks like it's going to give me negative 44 as a value. All right, so what do you notice about this next one? Can you see it? So if I go to list my i's, I know that I'm starting at my I is equal to 1, and I'm going to go 2, and I'm going to 3, then I'm going to go 4, and I'm going to take a look and say, wait a minute, how high do they want me to go? And when I look here, I'm like, wait, what? I'm going to keep adding forever. And because there's always going to be one more value towards infinity, this is the one that logic tells me I can't find the sum, because this is an infinite series and you cannot find the sum of an infinite series. So we can go back up to those notes and say, if your series is infinite, you can't find the sum. Okay, one last one. Let's see how we do on this one. And now it makes sense to us why they say round to decimals if needed, because check out who's visiting. Our dear friend E. You're like, I understood it up until the E showed up. All right, my first value for I is going to be 0 because that's my start. I want the sum of all of the elements in the series from I is equal to 0 to I1 and then 2 and then 3. And how do I know where to stop? Right here. 4 tells me where to stop. All right, so let's go ahead and see what we got here. The opposite of 1/3, and that's going to be times e to the I power, plus the opposite of 1/3 times e to the I power, plus the opposite of 1/3 times e to the second power, plus the opposite of 1/3 times, I'm running out of room, e to the third power, and then plus the opposite of 1/3 times e to the fourth power. Now you and I both know I definitely need a calculator for this one. So let's go ahead and talk about what it is that I have to enter in. We'll go to my home screen, clear everything out. So I have the opposite of 1 divided by 3, and we'll talk about some shortcuts to do this. So 1 divided by 3 times, oops, I don't want to do that. I want to do times, here's my e, and then to the 0 power. So what I'm going to do with my calculator is I'm going to take this just one at a time, because guess what? When I do that, it calculates my value. Hey, doesn't that make sense? Anything to 0 power is 1, and negative 0.333 is 1. So we're doing okay so far. Check this trick out. Are you ready? If I just continue on with a plus sign, it's going to take this past answer and add it to negative 1 divided by 3 times e to the, which power now? Yeah, first power. So we'll go ahead and hit enter. So what is it's done? It's taken a third, because order of operations, it's going to have me doing e to the first, which is 2.7, negative 1/3 times 2.7, and then that negative value added onto that. Okay, guess what? I'm going to be adding. Oh, I didn't mean to do that again. Friends, hold on. I'm going to clear out. I'll be right back. All right, so here's what we want. We want to make sure we hit the plus sign. And we're going to add, here's e to the 0, here's e to the 1, next comes e to the 2. Negative 1 divided by 3 times e to the second power is going to be equal to, and then we're going to add it to negative 1 divided by 3 times e to the, and here I'm up to my third power, equals plus negative 1 divided by 3 times e to the fourth power. Now you're like, when do I stop? How far do I go? Okay, you're done. Because here's how you know where to stop. You were told to do it from a value of 0 to 4. So here was e to the 0, here's e to the first, e to the second, e to the third, e to the fourth. And this funny looking symbol here says add them all up together. So this value that you get, negative 28, what did they tell us to round to? 2 decimals. So it looks like that our sum is equal to negative 28. And when I look at 0.597, I'm going to round that up. So it's going to be 0.60. So that summation tells me to add up each of those terms. Okay, let's check out and see what's on the back. Write the series in summation notation. we may need to determine if the series is arithmetic or geometric and then find an explicit formula. So here's the interesting thing. We're going to do geometric next class. So just as a little foreshadowing, a geometric sequence is when you have a set of numbers that have a common ratio. So something tells me this one's going to be the one that we skip and come back to later. All right, let's see what it tells us to do first. All right, so let's read these directions. Write the series in summation notation, which means we're looking for some kind of sigma. And we're going to look at where we're going to start, and we're going to try to fill that box in, and where it ends, and we'll fill that box in, and then here's going to be the rule. So our job is to fill in each of those boxes. So let's take a peek at this series and see what's happening. I know it's a series because I see plus signs, and I know it's a finite series because there's no dots. So it's good to go. When I look and see how I get from 4 to 8 and how I get to 8 to 12 and how I get from 12 to 16, I see that each one of those has a difference of 4. So I agree it's arithmetic, and I see it has that difference of 4. So I'm going to go ahead and go get my arithmetic formula. I'm going to say that any number in that formula is equal to my first number plus the difference times my n minus 1. So let's see what I can fill in and see if I can come up with my rule. Remember, this is supposed to help me figure out what my formula is. So any number is equal to this first term, there it is, that first term, plus my common difference, guess what, there it is, times my n minus 1. So I'm going to simplify this. A sub n is equal to 4 plus 4n minus 4. So any value is equal to 4 times n. All right, guess what we just found? We just found the rule that's happening for these equations, because I know that 4 times 1 is 4, which means my rule starts with 1 and it goes up to 4. So when I go to write this in summation notation, I know that I start at 1, I go to 4, and because that's my rule, I know that I'm substituting each of those values in from 1 to 4 and then adding them up and summing them together. Now remember, I didn't find the sum. I just was able to rewrite it in summation notation. All right, let's try another one. Let's get our boxes set up and we'll do a little bit of a better job. This is where my series ends. This is my sigma. This is where my series begins. And this represents my rule. So we have a little bit more room for this one. All right, let's see what happens here. I have definitely have a series. So I'm going to go, because I see those plus signs. So I'm going to see if I see a common difference. So I have 1 plus 3 and 4 plus 12. It's not the same. So when we talk about, is it arithmetic? The answer is no. So for this one, we're going to skip it and we're going to come back to it when we talk about a geometric series, because guess what? This is an example of a geometric series. All right, let's take a look at 7. When we look at 7, we want to first find our common difference. If we're writing it in summation notation, we're going to have where we start here, we're going to have where we stop, and then we're going to have our rule. So that's what we're looking for. And our first job is to determine, is it arithmetic, because that's what we're dealing with this go around. So I have plus 3, plus 5, plus 7. It's not going to work. So it's not arithmetic. So guess what? You get to skip it. You know, you're like, yay. All right. Some of the first 10 terms of the geometric, guess what? We're going to come back and do that one at a later date. All right. So here's this next and final concept we're going to talk about, and that is evaluating our arithmetic. If we have a finite arithmetic series, now we were only able to figure this out or add all those things together when we did it by hand. But if you have an arithmetic sequence that's finite, you can find the sum of the series by using this formula. And it's actually a pretty cool conversation. One of the SAT questions that they love to ask you is, can you find the sum of the numbers of 1 to 100? And everyone's like, sure. But then it's a timed test, so you spend far too long doing 1 plus 2 plus 3 plus 4 plus 5 plus 6 all the way to 100. So the conversation is, okay, can we solve a simpler problem? Let's think about the sum of the numbers from 1 to 10. If you think about the way that that works, if I added my first and last terms together, do you see how I'd get 11? Well, what if I added my next terms together, 2 and 9? Do you see how again I get 11? Okay, well how about 3 and 8? Oh, look at that. Well, how about 4 and 7? Aha, look at that. Okay, well, you know what's happening next. What about 5 and 6? Ah, check it out. So what we can end up doing is a lot of times we can find half of our first and last terms added together times that n. So if you add these together, I have 11 plus 11 plus 11 plus 11 plus 11. 1, 2, 3, 4, 5 sets of 11. So if I was adding the numbers up to 10, I would take 10 divided by 2 and multiply that by that sum of that first and last term. So that's where this formula comes from, a common SAT question that they love to put on those tests that they like you to do. Okay, maybe you want to think about it this way, and that's up to you. If you're a plug and chugger, you can go ahead and plug in whether I have my first term, my nth term, and that can help us find it if I don't know which of those terms I'm finding. All right, let's try some sample problems. I want to find the sum of the first 30 terms of the arithmetic series. So here's my first term, and I'm going up to my 30th term. So my n is going to be equal to 30. So let's go ahead and plug in what we know. All right, so let's talk about what we have. When you're looking at these two formulas, I want to go back and remind you of how we find any term in a sequence. If we don't have our first term, then we're going to need to embed this term in for finding that first term, and that's where that 2a sub 1 plus n minus 1 times d comes from. So let's talk about this. Find the sum of the first 30 terms of the arithmetic sequence. So we have the sum of the first 30 terms is going to be equal to, and we're going to go ahead and take that 30 and divide by 2. And then we're going to multiply it by these values here. So 2 times a sub 1, and my a sub 1, here's my first term, is times 3. And then we're going to go ahead and add that to what we know our common difference is. And if you look here, as I go from each term to the next, my common difference is 4. And that's going to happen 20 9 times. So the reason why I'm able to use this formula is because this a sub n, I don't know what the 30th term is. So if you need to find what the 30th term is, you would have to say that a sub 30 is equal to my first term, which is 3, plus my common difference, which is 4, times my 30 minus 1, 21 times. So what you end up doing is this formula is embedded here. See how there's 2 a sub 1's? There's my 3 that would have been here for the first term and here. So we can combine both of these formulas together by using these. Alright, so my S, my sum of the first 30 terms is equal to 15 times 2 times 3 is 6. Plus 4 times 29. And if you want to make sure you're not screwing up the math, go ahead and get your graphing calculator. And you can go ahead and say 15 times 6 plus 4 times 29. That's the greatest thing. Your calculator knows order of operations. And as long as you get all your parentheses right, you're in good shape. So the sum of all those terms, the sum of the first 30 terms of that sequence is 1,830. Find the sum of the first 25 terms of the arithmetic sequence. All right, it's told us it's arithmetic sequence, so we don't have to worry about that. When I look at this, can you see what our common difference is? Yep, our common difference is going to be 3. Now, you have a choice. You can do this and this formula, or you can do just this one all at once. So you can say that the sum of your first 25 terms is going to be equal to that 25 divided by 2 times twice my first term, which is 2 times 5, plus n minus 1, 25 minus 1, times d, which is my common difference. So my 25 terms all added together are going to be 25 halves times 10 plus 24 times 3. And that's close enough now to when I can go ahead and jump in and use the calculator. So I can say that 25 divided by 2 times 10 plus 24 times 3. Make sure I have all my parentheses closed. And I have the sum of the first 25 terms of that sequence is 1,025. Okay? All right. The sum of all even integers from 2 to 70. Let's think about this. So, the sum of all the even integers from 2 to 70. Well, how many are they? I know right away, we'll change colors. I know right away that my difference is going to be equal to 2, right? But do I know what my n is equal to? So that'll be an interesting question for us to figure out as we go through this. Okay, so I want you to think about what I've done on this one. I know that if I know my first and last term, it's a simple equation. The sum of all those numbers is going to be equal to that number divided by 2 times the sum of my first and last term. But I don't know this n. So that's where I come over to this conversation. I know that a sub n, any term in my series or my sequence is going to be equal to the first term plus that difference times 1 less than how many terms I have. So guess what? I have a formula where I can plug in everything I know and solve for what I'm missing. My last term is 70. My first term is 2. My common difference is 2. I want to know what term is 70. So then I can go ahead and just solve this equation. 2n minus 2. So 70 is equal to 2n divided by 2. So my n is equal to 35. Bingo. So my sum of those first numbers is going to be 35 divided by 2 times 72. So I'll go ahead, and when I add up those numbers, I'm going to say 35 divided by 2, and that's going to be times 72. So the sum of all the even integers from 2 to 70 is going to be 1,260. So these numbers are always going to be, these formulas are always going to be given to you. I want you to have them handy and make sure that you're familiar with them to know how to work them. Okay, so here we have the concert hall. The concert hall has 25 seats, and each row after that has one more seat than the row in front of it, and there are 32 rows of seats. So if I have 25, and then I have 26, and then I have 27, and I have 28, what I have is n is equal to 32 rows. My first set of rows is 25, and I go up 1 each time. 26, 27, and 28, which means my D is equal to 1. So when I write an explicit rule, I'm going to go ahead and say my number of seats in that nth row is always going to be equal to my first term, which is 25, and that's going to be plus my difference, which is 1, which is going to be equal to n minus 1. So then I can say any term is going to be equal to 25 plus n minus 1. So my rule, once I simplify everything, is going to be n, whatever row that is, and it's going to be plus 24. And that's going to tell me what row my, so my 32nd row is going to have 32 plus 24. Okay, if 35 students want to sit in the same row, what rows can they sit in? So they're not going to be able to sit in 25, 26, 27, 28. So I need to make sure that my number of seats in the row is going to be 35 or greater. So let's go ahead and say if I want to know where there's 35 seats in a row, A sub n is going to be equal to, I can use this to tell me n plus 24. So if I subtract that from each side, it looks like I get 11. So they have to go 11 or greater. 11, 12, 13, 14, 15, 16 total. Okay, so how many seats are in the concert hall? That's asking for the sum. And the sum of all of those numbers that I have. So when I look at all my numbers together, I know that I have, we can go up and use these formulas here. So I can say the sum of those 32 rows is going to be equal to my 32 divided by 2. I'm using this formula here. And that's going to be times twice my first amount, which is 25 seats. And then it's going to be plus my n minus 1. So that sounds like it's going to be 31, 32 minus 1. And then times my difference. My difference is, of course, 1. So we'll go ahead and enter that into the calculator, where I have 32 divided by 2 is 16. I'll go ahead and just start friendly. 16 times, we'll go ahead and say, 2 times 25 is 50, plus 31 times 1 is 31. So that means that there are 1,296 seats. All right, you did a great job. Good luck with the math space. We'll try to keep it short for you. So you're just playing with this and doing a little bit of practice. And don't forget the e-cart. We'll keep that short for you too, because I know you had a hard week with taking your test and doing all this new stuff. So hang tough with this. Talk to you soon.